Hello everyone, this is Samit Sankarnavar. I am back with new video providing detailed revision of one more interesting chapter from SSLC Mathematics. As you might have already seen in this video thumbnail, today's our focus of discussion is going to be on the chapter triangles. So let us start with the very basics of triangles. Let us first understand what is a triangle. Basically, a polygon having three sides is called as a triangle. If you want to see how triangle looks like, here in this figure ABC is termed as a triangle. Figure ABC is termed as a triangle here. Now let us understand what are the different parts that are present in this triangle. First of all, we have three sides, that is AB, BC and AC. These are the three sides of triangle. Then we have three angles. Angle between side AB and AC is called angle A. Angle between side AB and BC is called angle B. Angle between side AC and BC is called angle C. Next, we have three vertices, namely A, B and C here. You can see these are the important parts of this triangle. Now, we have different types of triangles. If all the three sides of a triangle are equal, then that triangle is called as equilateral triangle. If only two sides of a triangle are equal, then that is called as an isosceles triangle. Similarly, if angle between any two sides of a triangle is going to be 90 degree, then such a triangle is going to be called as a right angled triangle. So these are the important terminologies related to triangle. Now there are another two terminologies that we are going to frequently use in this chapter. Let us see what are those terms. They are nothing but median and altitude. There is a very minute difference between median and altitude, but they create a lot of confusion while solving the problems. So let us understand what is median and what is altitude. A median is a line drawn from one vertex of a triangle to the opposite side of that vertex. Median divides that side into two equal parts. Suppose if I take example in this triangle ABC, I draw from vertex A line that is opposite to the side of that vertex, that is BC side. I am drawing a line that is AD. AD line here, it is going to divide this BC line into two equal parts, namely BD and DC. Therefore, I can call this AD as median of triangle ABC. Remember, the angle between AD and BC need not be 90 degree, it can have any oblique angle. Similarly, if I consider altitude, altitude is also a line which is drawn from one vertex of any triangle to the opposite side of that vertex, but that altitude is going to make angle 90 degree. Here you can see AD is making 90 degree to the side BC. In this case, it cannot divide BC side in the equal parts, that is BD and DC. Here BD and DC are not going to be equal in case of altitude. There will be a particular case in case of equilateral triangle where median and altitude both are same. Means median itself is going to act as an altitude in case of equilateral triangle. We have studied about the triangles chapter in your previous classes. Now let us understand what is new thing that we are going to study in this chapter. If I briefly explain what you have studied in previous classes, we have studied about concept of congruency. Congruency is nothing but if two or more figures or objects are same in shape and size, color and looks, but not necessarily be in the same orientation, such figures or objects are said to be congruent figures or congruent objects. If I consider examples of congruent figures, I can say you can consider these two pens here. These are going to be of exactly same size and same shape. Therefore, we can consider these two pens as example of congruent objects. Similarly, you can see two triangles are present here. Again, they are kept in different orientation, but their shape and size is going to be exactly same. Again, therefore, this we can consider as an example of congruent figures. Similarly, you can see two squares are present here. Again, these are kept in different orientation, but their size and shape is going to be exactly same. Therefore, these are considered as example of congruent figures. The new thing that we are going to study in this chapter is going to be concept of similarity. If I explain what is similarity concept, if two or more figures or objects are same in shape and looks, but not necessarily have the same color or size, such figures or objects are said to be similar figures. If I consider examples of similarity, you can see here there are two pens that I have considered. having same size but and same shape also, but they are different in colors. We cannot call them exactly same objects, but we can call them similar objects. Therefore this is an example of similarity. Similarly, if I consider two figures here, this you can see two triangles I have considered. First triangle is very big and second triangle is small compared to the first triangle, but you can see that their shape is same and looks are also same, but their size is different. Therefore this is going to be an example of similar figures. Similarly, if I consider here two squares, second square is smaller than the first square, but their shape and looks are going to be very similar. Therefore we can consider these two squares as an example of similar figures. Now let us dive deep into the concept of similarity. Mathematically, we can declare any two polygons as similar if their corresponding angles are equal and their corresponding sides are going to be in the same ratio. When these two conditions are fulfilled, only then we can declare any two polygons of the same number of sides as similar. Let us understand how similarity of triangles is considered. Two triangles are similar if their corresponding angles are equal and again their corresponding sides are going to be in the same ratio or proportion. To understand this concept, I am going to consider an example here considering two triangles, namely ABC and A dash, B dash and C dash triangle. In these two triangles, you can see that AB side is in proportion with A dash, B dash side, means if I take the ratio of these two sides, it is going to be 6/3, that is equal to 2. Similarly, BC side is in proportion with B dash, C dash side, ratio of these two sides is also again going to be equal to 2, and AC side is in proportion with A dash, B dash side, ratio of again these two sides is going to be equal to 2. Therefore, I can say side AB and A dash, B dash are corresponding sides. Similarly, BC and B dash, C dash are corresponding sides. AC and A dash, C dash are one more set of corresponding sides. You can see that ratio of all these three corresponding sides are going to be equal, that is going to be equal to 2. And as all these sides are going to be in proportion to each other, we can also declare angle between AB and AC, that is angle A, is equal to angle A dash, and angle B is going to be equal to angle B dash, angle C is going to be equal to angle C dash, because of which these two triangles have fulfilled these two criteria, that is corresponding angles are equal and their corresponding sides are going to be in the same ratio. Therefore I can declare these two triangles as similar triangles. Now using this concept of similarity, we can prove any two triangles as similar depending on different theorems that we will be studying in next in this chapter. As we have understood the concept of similarity, let us now consider some important facts, and also we will see where this concept of similarity is going to be used in our day-to-day life. First of all, two similar figures have the same shape but not necessarily have the same size. In congruency of two triangles, it was very necessary to have the same shape as well as same size, but in similar figures we can have same shape but need not be having same size. This is one fact. Second fact we can consider as all circles are similar. You take any circle of different radius, all those circles are going to be similar to each other. Then all squares are going to be similar. You can see that all the squares are going to be always similar because angle between any two sides of a square is going to be always equal to 90 degree. You take any square, angle between any two sides is going to be 90 degree. Therefore all the angles, corresponding angles of all squares are going to be equal, and also their sides are going to be in the ratio or in the same ratio you can consider, because all sides are going to be equal. Therefore all squares are similar. Similarly, all equilateral triangles are similar. We have studied properties of equilateral triangles, that all the sides will be equal and all the interior angles of a triangle are going to be equal to 60 degree. When all interior angles are going to be equal to 60 degree of all the equilateral triangles, therefore we can consider any equilateral triangle of different sizes, we can consider them as the similar figures. Next, all congruent figures are similar, but similar figures need not be congruent. If you have two congruent figures, then you can consider them as also similar figures, but all similar figures need not be congruent. Means if I consider two squares of different sizes, they can be taken as similar, but we cannot declare them as congruent. If I consider two squares of exactly same size and shape, I can call it as congruent as well as similar. Hope you have understood this last point. Next, symbol used for indicating similar figures is going to be this, and you have studied in previous standard that this symbol we have used for declaring two triangles as congruent. These are the some important facts that you need to remember. This can be asked for 1 mark directly in the examination. Now let us understand where we are going to use the concept of similarity in our day-to-day life. First one is in preparing maps. You might have seen various maps like map of India, map of our state Karnataka, and other different maps of different areas. Maps, they are prepared as it is, how it looks on the ground, but with a proper scale. If scale is going to be like, for example, 1 centimeter on the map is going to indicate 1000 kilometer on the ground actually. Like this, with proper scale, smaller figure of the exact same actual figure can be prepared using this concept of similarity. Next, building plans are prepared. Any building which is going to be constructed, their plans will be prepared first in computer with smaller sizes, which can be utilized in order to prepare building plans, building constructions. Next, photography, etc. You can see that different while taking only one photo, they can prepare different size photographs. That is also using the concept of similarity. Now these are the three important applications that we have been using in this day-to-day life. Like this, we have many other applications of this similarity of figures that you will be studying as you go on studying in next standards. Now we are going to see some important theorems related to concept of similarity and related to triangles. Remember, theorems are the proven statements that we can use to solve multiple problems related to the same situation where whatever it has been considered for proving these theorems. So very first theorem is nothing but Thales theorem or basic proportionality theorem. If I read out the statement of this theorem, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. So a detailed proof for this statement is given in your textbook that you can go through. I'll just explain what is the meaning of this theorem. If I consider a triangle ABC here, and suppose I take any point on the side AB here, be it point D, I will call it point D. Now I start running this point such that it is going to be parallel to the third side, that is BC. Parallel to this side, I am starting a line and I am just extending this line such that that line is going to cut AC side at point E here. Now we can take that D is parallel to BC. When this is done, according to this theorem, we can have a very important result that D is parallel to BC. In that case, first result that we can see is, we can see here AD and DB, AE and EC. This DE line has divided this AB and AC into two parts, that is AD and DB and AE and EC. Now when I take the ratio of this, that is AD to the ratio of DB and ratio of AE to the EC, those two ratios are going to be always equal. This is the very first result and important result from this theorem we can consider. Now heading towards the second result, you can see that there are two triangles that are formed here, that is ADE is one triangle and ABC is our original triangle. Now you can consider these two triangles as similar triangles, that is AD is similar to ABC triangles. In that case, we have already studied two triangles are similar if their corresponding sides have the same ratio. Then we can write this result as AD upon AB are going to be corresponding sides and AE and AC are going to be corresponding sides. Similarly, DE and BC are going to be corresponding sides. Then they have to have the same ratio or proportion. Therefore, AD upon AB is equal to AE upon AC, that is going to be equal to DE upon BC. This is the second important result that we have considered. Now, if I just inverse all these sides, I will get the third result, that is AB upon AD is equal to AC upon AE is equal to BC upon DE. Remember, in second result we have considered ratio of corresponding sides of smaller triangle to the bigger triangle. Here in the third result we have considered ratio of corresponding sides of bigger triangle to the smaller triangle. So all these three important results can be used to solve multiple problems. That one problem we will take as example in the next slide, that I will show you how we can solve problems on this. Now, related to this theorem, we have one more theorem which is considered as converse of theorem 1, that is nothing but theorem 2. I'll just read out. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Here, DE line you can see, that is dividing AB in the same ratio as AD upon DB is equal to AE upon EC. Therefore, I can consider according to theorem 2 that DE line must be parallel to BC line. Only then that line will divide any two sides in the same ratio, that is AD upon DB is equal to AE upon EC. That is the meaning of this second theorem. Now we will see some examples related to these theorems in the next slide. Let us consider the first example. In the given figure, he is telling that DE is parallel to BC, then he is asking us to find what is the value of EC here. Now, using first theorem, if DE line is parallel to BC line, then according to first theorem we can write the result as AD upon DB is equal to AE upon EC. This we can write. Then all the values are given, I'll just substitute all the values. Then EC value can be easily found out by doing the cross multiplication. When I do cross multiplication, I get as EC is equal to 3 upon 1.5. Therefore, I got answer of EC as 2 centimeter. Like this, it is very important to write this one result from theorem 1. Similarly, one more example we have. Again, in this figure, DE line is parallel to BC line, he is telling. Then he is asking us to calculate AD value here. So we can write again, if DE is parallel to BC in this ABC triangle, then using theorem 1 we can write the result as AD upon DB is equal to AE upon EC. Therefore, easily AD value can be found out by doing cross multiplication. That is, AD is going to be equal to 1.8 into 7.2 will go on the right side. It is division here, it will become multiplication divided by 5.4 as it is. So when I solve this, I get AD as 2.4 centimeter. This is how we can easily solve any problem on theorem 1. Remember, many problems related to proving two triangles as similar or different sides in the ratio are present in your exercise problems. This is as only detailed revision. We are not going to see any problems of exercise. This was just for your understanding how we can use the theorem. Now we are going to see an important theorem which can be used in order to prove any two triangles as similar. That is nothing but theorem 3, AAA criterion of similarity of two triangles. Let us read out what this theorem says. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportion, and hence two triangles are similar. Suppose I have two triangles here, that is triangle ABC and triangle DEF. In these two triangles we can see, and suppose by some criteria, if we prove that corresponding angles of these two triangles, that is angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F. If we prove that these corresponding angles are going to be equal to each other in these two triangles, then automatically, according to this theorem, all the corresponding sides of these two triangles are going to be equal in ratios, and hence we can declare triangle ABC and triangle DEF as similar triangles. Remember, we have studied earlier that two triangles can be declared as similar only if all the three corresponding angles are equal and all the three corresponding sides are going to be in the same ratio. But according to this theorem, we need not prove both the conditions. We can only prove first condition, that all the three angles are equal, means all the three corresponding angles of both the triangles are equal, then automatically second condition becomes true according to this theorem, and hence those two triangles are going to be similar. Now this theorem can further be simplified using a concept that if two angles of a triangle are respectively equal to two angles of another triangle, then by angle sum property of a triangle, their third angle will be equal. Means suppose angle A is equal to angle D and angle B is equal to angle E, and angle C value and angle F value is not given to us, then we need not worry, because if angle A and angle B are equal to angle D and angle F, in that case, according to angle sum property, we know that sum of all the angles of an interior triangle is going to be equal to 180 degree. Means if these two triangles are going to be similar, then obviously this C and F angles are going to be equal to 180 minus angle A minus angle B, that is equal to 180 minus angle D angle E. If angle A and B are equal to angle D and E, obviously angle C is going to be equal to angle F. Therefore again we need not prove all three angles as same. Even if we prove only two angles of two triangles as same, automatically third angle becomes equal to each other, and hence we can declare again these two triangles as similar triangles. That is known as AA similarity criterion of two triangles. It says if two angles of one triangle are respectively equal to two angles of another triangle, then two triangles are similar. This is very important result. That if I want to summarize this entire theorem in simple words, if we prove only two angles of any two triangles as equal, their corresponding angles as equal, then we can declare those two triangles as similar triangles straight away. Now let us take an example on theorem 3. Suppose in this figure it is given that AE line is parallel to DC line, then we have to prove triangle ABE is similar to triangle BDC. Here it is given that A is parallel to DC, therefore we can take angle A is equal to angle D, because they are going to form alternate pair of angles for AE parallel to DC. Similarly we can consider angle E is equal to angle C, because again they are going to form alternate pair of angles for AE parallel to DC, and we can take ABE is equal to angle CBD, as they are going to form vertically opposite angles. Now we have proven that all these three angles of a given triangle are going to be equal. Therefore we can conclude that triangle ABE is similar to triangle BDC by AAA similarity criterion according to theorem 3. Similarly, you can approach any problem wherein we can, if you prove any three angles of a given two triangles as equal, or even if you prove only two angles of given two triangles are as equal, then you can easily declare those two triangles as similar triangles. Now let us see one more interesting theorem, that is theorem number 4, SSS similarity criterion for two triangles. SSS stands for side, side and side. Now let us read out what this statement says. If in two triangles, sides of one triangle are proportional to that is in the same ratio of the sides of other triangle, then their corresponding angles are equal, and hence two triangles are similar. If we carefully understand this statement, then we get to know that this theorem is exactly opposite of the theorem just we studied, that is theorem number 3. If I want to explain this theorem, considering two triangles here, suppose ABC and DEF are the two triangles, then according to this theorem, suppose triangle ratio of corresponding sides, that is AB to the side DE, BC to the sides EF, AC to the side DF are equal, then automatically all the corresponding angles, that is angle A will be equal to D, B will be equal to E and C will be equal to F. Now even if we prove that all three corresponding sides are going to be equal in ratios, then automatically their angles become equal, and hence both the criteria of similarity are fulfilled, and hence both the triangles are said to be similar. So you can see here AB upon DE should be equal to AC upon DF, that should be equal to BC upon EF if we consider these two triangles. Then A becomes equal to D, B becomes equal to E, and C becomes equal to F, and hence according to this theorem we can say triangle ABC is similar to triangle DEF. This criterion is referred to as SSS, that is side, side, side. Here we are proving three sides of any two triangles as their ratio as equal. Therefore we can prove by doing this that these two triangles are similar. Rest again we need not prove that their angles are equal. Only if we prove three sides, ratio of three corresponding sides are equal, that is more than enough to say that two triangles are similar. Now let us understand this with an example here. Here two triangles are given and it is asked us to prove that these two triangles are similar. You can see that this side with 9 units is in proportion with side with 3 units. 12 units side is proportion with side of 4 units. 15 units side is proportional with 5 units side. Therefore we can take the ratio of all these three corresponding sides. So they are all going to be equal to 1 by 3. Therefore we can see that all the corresponding sides are ratio is going to be equal. Therefore from SSS similarity criterion we can say that triangle number 1 is similar to triangle number 2. This is how we can approach problems related to side similarity criterion when only value of all the sides of two triangles are given and no angle is given. Next theorem that we will be studying is theorem 5. This is going to be the combination of theorem 3 and theorem 4. Let us see what is theorem 5 is. This is nothing but SAS similarity criterion for two triangles. SAS stands for side, angle and side. Let us read out what this theorem says. If one angle of a triangle is equal to one angle of other triangle and the sides including these angles are proportional, then the two triangles are similar. If you want to understand this theorem in detail, suppose there are two triangles, that triangle ABC and triangle DEF. In these two triangles, if angle A is equal to D, and angle sides including these two angles are in equal proportion, that is AB upon DE is equal to AC upon DF, or in case B is equal to angle angle E, then angle sides including these two angles, that is AB upon DE is equal to BC upon EF, or angle C is equal to angle F. In this case, angle including sides including these two angles, that is AC upon DF, should be equal to BC upon EF. Any one condition among these three conditions is seen in any two triangles, then we can directly say that these two triangles are going to be similar. This is known as, we are saying that one angle and two sides. Therefore I can relate this as side, angle and side similarity criterion. Side, angle, side. You can see here one side, angle comes in between, then another side. If this condition is fulfilling in any two triangles, we can declare that these two triangles are going to be similar. Okay, this is known as SAS similarity criterion. Now here again we did not prove all angles as equal, we need not prove all sides are going to be in equal proportion. We just need to prove two sides and one angle including those two sides is going to be equal or in equal proportion, and that is more than enough. Now let us take one example to understand this. Suppose in this diagram AB is parallel to DE, DE is here, A is parallel to DE, then L value is asked, L is here. Now using any one criteria from these three criteria, that is AAA or SSS or SAS, we can prove first these two triangles as similar. So let us take AAA criteria. Here angle A is going to be equal to angle E because alternate pair, again angle B is equal to angle D, again alternate pair of angles, and we can see that angle ACB is equal to angle DCE, that is going to be because vertically opposite angles. Therefore what we can say here is triangle ABC is similar to triangle DCE because of AAA similarity criterion. Now if I want to apply this SAS similarity criterion, if two triangles are similar, I can write as angle AC upon CE should be equal to AB upon DE or ED, I can say. Now we have all these values. Considering all these values, we can substitute ED value is L. By cross multiplication, L is equal to AB into CE upon AC. AB value is 10, CE value is 8 and AC value is 4. Therefore, by solving this we get L value as 20. Like this we can first prove any two triangles are similar using any of the criteria, then we can find the required values. Next theorem is very interesting. Theorem number 6. This gives us an idea about area of similar triangles. Let us read out what this theorem says. The ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Let us understand this theorem. Suppose there are two triangles here, triangle ABC and triangle PQR. In these two triangles, suppose if we consider, if we have already proven somehow that these two triangles are similar, in that case ratio of area of ABC to the area of PQR is going to be equal to square of ratio of any one corresponding side. It may be AB and PQ, it may be BC and QR, it may be AC and PR. This is going to be very important result. Using this we can solve many problems. Now this theorem is very important for proof, like for 3 or 4 marks that has been given in your textbook. Here we are not going to discuss a proof of this theorem. We are just going to discuss some important points related to this theorem. Now let us understand this theorem with an example. It is given that suppose triangle ABC is similar to triangle PQR and the ratio of any two corresponding sides of these triangles is 2:3. Then what will be the ratio of their areas? Suppose two triangles are given and one corresponding side, ratio of one corresponding side is given, that is 2:3. Here we can take, and what is asked, ratio of their areas is asked. So I can write this in the form of this theorem, that is area of ABC to the area of PQR should be equal to ratio of any one corresponding side and square of that. So ratio of one corresponding side is given, that is 2/3. I just need to square of this, then I will get the ratio of their areas. That is as simple as that. Now I just square this. Area of ABC to the area of PQR is going to be 2 square is 4, 3 square is 9, that is going to be 4/9. Therefore answer is going to be 4:9. Now you can expect many different types of problems on this area of similar triangle concept that you have to solve through your textbook problems. Now let us see some important results what we have got from area of similar triangles theorem. These results are going to be very useful for your quick calculation in the examination. These results are going to save a lot of time for you. So what are those results? Let us see. First one, suppose in your exam ratios of corresponding sides are given of any two triangles and you are asked to calculate ratio of areas. They are going to be just equal to square of whatever ratio of areas is given. Suppose ratio of corresponding sides is 2, then ratio of their areas is going to be 4 times 4. Then ratio of corresponding side is 3, then ratio of corresponding areas will be 9. Ratio of corresponding side is 4, then ratio of areas of two triangles will be 16. Ratio of corresponding sides is 1:2, then corresponding areas will be 1:4. Ratio of corresponding sides is going to be 1:3, then ratio of areas will be 1:9. 1:4, then ratio of areas will be 1:16. Like this you can remember these values for your quick calculations. And anything reverse is also possible. Ratio of areas will be given and ratio of corresponding sides will be asked for your calculation. So you should be aware what is asked and what is supposed to be calculated, and accordingly you have to calculate the values. If ratios of areas is given, then you need to take the square root. If ratio of corresponding sides is given, then you need to take the squares of these values. Second important result is, if it is given that two points are midpoints of two sides of given triangle, then the area of given triangle is 4 times the area of triangle formed by joining the midpoints. Suppose ABC is the given triangle, and in the problem it is given that D and E are going to be midpoint of AB and BC, and Now you can see if we join DE, another triangle we have, that is BDE triangle. Then ratio of area of BDE triangle to the area of ABC triangle is going to be equal to 1:4, or area of this big triangle is going to be 4 times of area of this small triangle, that is BDE. Area of small triangle is 1/4 of area of big triangle, or area of big triangle is 4 times of area of small triangle. This one statement is very important. Many times it has been asked in the exam. It can be taken as a direct result and it can be used in the exam. Next, one more important result that we have obtained is ratio of area of any two triangles is going to be equal to ratio of corresponding median square of ratio of corresponding medians. Not only sides, not only area of any two, ratio of area of any two triangles is equal to square of ratio of only corresponding sides, it is also equal to square of ratio of its medians. Now what is median? You have already studied earlier when we started this video. Now we just need to go back to the initial part and understand what is the median, and remember this important result, and you can try this also by proof. Now we are going to see two more theorems. These two theorems are so important that they have created revolution in the history of mathematics. So let us see what are those theorems. First, theorem 7, that is, if a perpendicular is drawn from the vertex of right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Let us understand this with the help of diagram. Suppose ABC is a given right angled triangle here, where AB angle is going to be 90 degree. Suppose we are going to draw an altitude here, that is BD is going to be altitude, that is going to be perpendicular to side AC here. In that case, BD is dividing ABC triangle into two parts. You can see here, that is ABD triangle and BDC triangle. Then ABD triangle and BDC triangle are similar to each other. Also, ABD is similar to whole triangle ABC and BDC triangle is similar to whole triangle ABC. Means these three triangles are similar to each other. This is what this theorem 7 is trying to tell us. Now using this one theorem, mathematician called Pythagoras gave a wonderful result which has been used by so many mathematicians and other engineers to prove their different concepts. Pythagoras theorem states that in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. Let us understand again this with this diagram only. According to Pythagoras, he is trying to tell us that square of longest side of a right angle triangle is equal to square of sum of other two sides. That is, in this triangle we can say AB square plus BC square is going to give us AC square. That is what this theorem says. Now remember, theorem 7 and theorem 8 is applicable only to right angled triangles. Now let us understand Pythagoras theorem with an example. Suppose in this given figure ABC, it is a right angle triangle. Then it is given that AB is 6 cm and AC is 10 cm. Then what is the value of BC? Now it is asked. Now if I write it in the form of Pythagoras theorem, I can write that AB square plus BC square is equal to AC square. But I know AB value and AC value, I don't know BC value. Therefore, keeping BC on the left side, I will take AB on the right side of the equal sign. Therefore, BC square is equal to AC square minus AB square. Now if I substitute the value of AC square, that is AC is 10, 10 square is going to be 100, AB value is 6, so AB square is going to be 36. Therefore, BC square I am getting as 64. Now square root of 64 I have to take in order to obtain BC value, that is square root of 64 is going to be 8 cm. Therefore value of BC is going to be 8 cm here. Now like this, using Pythagoras theorem we can find the value and multiple results in related to right angled triangles. Next theorem is theorem 9. This is just the converse of Pythagoras theorem. This theorem is going to be the last theorem of triangles chapter, and let us understand what this theorem is trying to tell us. I will just read out the statement. In a triangle, if square of one side is equal to the sum of the squares of other two sides, then angle opposite to the first side is a right angle. If let us understand this theorem with diagram here. Suppose ABC is any triangle, and according to this statement, if AC square, that is longest side square, that is AC square, is equal to sum of other two sides, that is AB square plus BC square, then side opposite to AC should be angle opposite to AC side, that is B should be equal to 90 degree. And in turn, if any one angle is equal to 90 degree in a given triangle, that triangle is considered as right angle triangle. We can write it in this way: if AC square is equal to AB square plus BC square in any triangle, then ABC is considered as a right angle triangle. Now with this we are going to end this detailed revision of this chapter. There are many interesting problems in this chapter that you have to study on your own. I'll just end up this chapter with this one theorem. So let us meet in the next video. We are going to whatever I will be bringing for your revision. Till then, have a good day and take care.